Okay, good morning. So we took a very simple element for the two dimensional problem, and so my interest, you must have seen the way I teach, that is even for finite differences. First I did one dimensional BVP, then two dimensional BVP, just introduction how to find out how to deal with two dimensional problem, then one dimensional transient problem, and same thing now we are doing it for finite element method. So, after I complete this, that means 1D BVP is over. Now, introduction to 2D I have just spent one lecture, and after we complete this, then I will go to transient problem. And we will see. So, yesterday we saw how to find out the shape functions for a triangular element. Simple. It is the simplest element. So, these days some people also call it simplex element, simplex, SIMPLEX. I cannot tell you because I am taking a problem from quasi harmonic equation, governed by quasi harmonic equation. So, I cannot tell you. You see, I think for one dimensional I showed you that second order problem, when you go to structural engineering, also occurs for axial deformation of a bar. You please derive that equation. I have given you the equation, you please derive that equation. How that second order equation in E A times d square u by dx square equal to p, where p is axial load as a function of x comes. So, now in two dimension this we have got now this quasi harmonic equation. It will be very interesting to know that this again defines, when you go to structural engineering, it will be problem of plane deformation, in plane deformation. So, planar problem, if the loads, if there is a planar body, very thin body, and all the loads are applied within the plane, nothing is perpendicular to the plane, then the movement of particles within the plane can be found out from this quasi harmonic two dimensional. So, this is also there. So, it is called 2D elasticity problem. So, 2D elasticity problem also is governed by the same equation. So, like plane stress, plane strain, axisymmetric, these are the three classes of problems that comes under. See, do not be silent, you have to broaden your outlook, horizon. So, in plane problems are three types. When you go to elasticity, one is called plane stress, other one is plane strain, and third one is axisymmetric solid. If the solid is axisymmetric, both geometry as well as loading. How do you form axisymmetric solid? Like a cylinder. How do you form a cylinder? You have a plane, rotate about the axis, you will get a cylinder. It can be also hollow cylinder if you just display. And then if the loading is axisymmetric, then every plane of this cylinder, radial plane, behaves in the same manner. So, why do we analyze the whole structure? We can analyze only the plane. So, three dimensional problem need not be solved. So, this also governs the, and when we, because this element was not developed for solving a mathematical problem of quasi harmonicity, it was developed for solving plane stress problem, by the way. So, in plane stress, this turns out to be that this triangular element within the triangular element you will find that stress and strain will be constant. That I am not taking up, but I am just giving you. So, it is also known by constant strain or constant stress triangle. So, originally when it was developed, it was called constant strain triangle. That means, within the element strain is constant over the entire triangular area. Once strain is constant, stress also will be constant. So, it was known by, but then I cannot tell you for quasi harmonic the same thing, general equation. So, I do not want to make any, because I have not derived the equations of elasticity here. So, keep that in mind. So, it is a simplex element, and yesterday we saw that yes, phi hat within the element can be interpolated between the 3 nodes by this formula, okay, where shape functions are explicitly defined. Initially, it will take some time for you to go through the whole thing, but then all this definition of A 1, A 2 also I gave you, that these are like this: A 1, A I, B I, C I is given by this. Once you have this, now triangular is not a triangle is all right, but triangle in space in plane. See this triangle, if this is your x and y. So, the problem with triangle is, see, even if you keep one side of the triangle parallel to one of the axes for the sake of simplifying the integration, other two sides cannot be. So, we cannot take a, normally what we do, we take area dx dy, this is dA, this one is dx, and this one is. So, here now how to integrate this area, because I have to integrate the function over this area, and now it is not a very convenient way of, had it been rectangle or, and if the sides had been parallel to x and y, then it is easier to integrate. So, here the integration poses integration, although the element is simple, but integration over triangular domain, domain means area, does pose problem, not straightforward. So, this is the only thing. Any function if you want to integrate over triangular area. So, when this was developed, it was okay, but then for some simple configuration, right handed, you can have triangle of this type. In which this is parallel to one side, right angle triangle. In that case, what you can do, if you have this area, this can be moved from this point to this point, but within this is the line of, this is the, you have to say that what is the equation of this line. You have to ensure that it does not go beyond, it always remains within the equation of line. Then only we can find out the area. So, originally it was done, then what happened that of course, anything that gets developed is always, first you are very happy, then soon you realize that when you start solving or applying to problems, this problem was coming, this other problem. So, integration was a big damping factor in the beginning of the development of a triangular element, integration part. Then they developed what is called area coordinate. What is the meaning of area coordinate? So, I will just give you an example. If you have a triangle what is an area coordinate? If 2, one can be started from anywhere as long as you are having you are following this rule 1, 2, 3. Then if I have a node inside anywhere, if I have a node inside and I join the 3 vertices to this, so I call, I will just tell you what I call. Now let me draw a line parallel to base here 1, 3, and then this is some height. Let me also draw a line parallel to 1 and 3, and then this will be the height. Okay, 1, 2, 3. Now let me hatch this area. 1, 2, 3. So, we define like this, the area of 1, 2, 3, let us call this is area, triangular area 1, 2, 3, 1, 2, 3 is A or delta or whatever you want to call it. This will not come properly. Now, if I have taken a point like this, so I define the 3 sub areas in such a way, the area which is opposite node 1, I will call that as A 1, opposite 2 that is A 2 and opposite node 3, and I will give you the reason 3, such that A is equal to A 1 plus A 2 plus A 3. Total area is 3 sub areas. So, if there is something area coordinate, what is that area? You see, by moving this node O, let us call that O, the central node is O, I mean this inside node is O. If I move this, if I take this node to 2, then A 2 will become equal to A. If I take this node to 1, then A 2 will become 0. If I take this node to 3, then again A 2 will become 0. So, I define a something, I define a coordinate, I call L 1 ratio of the 2 areas. L 1 is A 1 by A, this is the ratio of quantities. L 2 A 2 by A and L 3 A 3 by A, such that in general any L I is A I by A. I can also explain this if this. Now, these ratios of the areas, I mean, and they have the properties, just now we saw that they have the properties same as what is the property of L 1 by the way? L 1 is 1, L 1, the value of L 1 is 1 at node when O coincides with node 1, and it is 0 when node O coincides with 2 and 3. So, I can say that L I is now similar to whatever we know about N I's. There is some relationship. By doing this, we have got this L I and N I are same. So, these ratios are called area coordinate, and it has come helpful in then you might have also seen earlier that Ni has a property. It is unit at the node under consideration and 0 at all other nodes. And the other property, I think I did not tell, perhaps I forgot, is if you sum all Ni's, all in any domain, that will always be equal to unity. See, like linear element 1 minus x by L of a linear element and x by L. These are the shape functions of and if you sum this, it will be. So, you take any one n number of, and you will always find that this is another property. So, here also we are finding that sigma A is same as sigma A I is equal to A, plus it has got the same property, that unity. So, this helps us this and there is a paper. Now, this was done by a mathematician. I mean, because when engineers confronted this problem, so this one was, there is a paper by Eisenberg, EISCN MA. And Malvern. LE. These are the two people. So, they wrote a paper in way back in 1973. In fact, they have generalized on finite element integration. In natural coordinates. And the paper is International Journal for Numerical Methods. In engineering. Volume number 7, page number 574 to 575, only 2 pages. Okay, so they have explained. Now, of course, it has come in books also, but that was the now they have given us some formulae how to find out. Now, I will not go into the derivation, because we will take only the results directly from how it helps. So, integration formulae, what are the integration formulae that they have given? One integration formula that they have given is, if you have to integrate over a surface and it is, you have L1 to the power A, L2 to the power B, and you want to, this is the line integral, S is line integral, not the curve. Then it is factorial A, factorial B divided by A plus B plus 1 factorial times the total length of the curve. So, this, if you want to integrate using now area coordinate, then if you have this kind of function, then it can be integrated like this, simple. Similarly, over area, if you have to integrate L1A, L2B, L3C, if you have 3, something like this function, then they have come up with a formula which is factorial A, factorial B, factorial C, A plus B plus C plus 2 into twice area of the triangle. Directly we can get this integral. So, we do use this formulae whenever we use triangle. Okay. Now, what was your element stiffness matrix? Huh? Did we study general formula? So, what was the general formula? K I j 1, any term of the is given by k is there, k is constant, of course, k is constant. No, so I will write it. Okay, then what else? Any area or something? What else? Integral dA, that is all. So, this integral dA, this is what is k. This is where. Now, since you have got now shape functions ni is there, I think just now we saw. Yes, ni is already, ni is equal to 1 by, shall I change to, let it be there, okay. Ci, this is shape function. So, for example, del ni by delta x will be given by 1 by 2 delta just b I. Then dni by dy will be 1 by 2 delta Ci. Of course, b I c I has to be properly taken from the coordinates. They are all functions of the coordinates of the nodal coordinates. Now, if you substitute this here, so k I j can be written as integral over area or dni by dx. Now, first of all, there is area two area. Now, this also will give you, so twice. So, 4 delta square. So, 1 by 4 delta square area square. Is it okay? Because product times this is what dni by dx bi k bj plus ci k cj. So, this is now you see what is the, these are all functions of coordinates, whatever, that means they are all constants. There will be some number, na, bi, ci, ai, everything, because only difference of coordinate, product of 2. So, this has to be done, but then these are all constant. K, if k also is constant, which we have written here. So, that means this whole thing is constant. This is area, this is also constant. So, everything can be taken outside the integral sign, and this is area integral of a triangular area. So, area will come there. So, it will be finally, it will be simply k times bi bj plus ci cj divided by 4, because one delta will be, if you integrate triangular area you will get a. So, this one will be 4 delta. So, we have got a simple formula to compute our k I j, any term of k I j, which can be done easily. Load vector it is not singly. Once I write area means it is double, nothing is single. Integral is double, but double integral over area of a triangle is just simply triangular area, na? So, that is delta. Because it is a constant, this comes out to be constant. So, it will come out of the integral sign, then area integral of over a triangle. So, that will give you only a, I mean delta. So, that is how it will be. So, it is constant. What is I am saying that k I j for every element is constant. That means, k of the total element or total domain is constant. So, this one is a constant. Now, you should ask me a question, sir, if it is constant and if you take the total domain, then what variation? Because in the entire is the stiffness, if k property is constant, then what are we talking? It must vary from point to point. Yes, if you discretize it, so for each element, each subdomain it will be constant. When you go to the next one, it will be different, because coordinates will change there, next one. So, it will be different, though there will be jump. The moment you go from one triangle to another triangle, there will be sudden jump. So, there will be jumps. Now, these jumps can be reduced by taking more number of elements, but otherwise there is a sudden jump, step from element to element. Now, if you have nodal force vector, means we are talking of this p vector. Now, p vector is given by p, I mean in fact ni, but then I have to write here pi, then I will write it pi ni p into dA over area. Now, this is PdA. Now, Ni is not constant. Here comes, see, this is not constant. Derivative turned out to be constant. Shape function derivative, because they were linear functions of x and y. So, if you take derivative with respect to x or derivative with respect to y, that turned out to be constant, but not Ni. So, it is not a constant. So, life is not easy here, we cannot just integrate area. Now, so this is little tricky, and again I think as problem comes we will see, but then these two mathematicians they have given a formula where this can be found out, that if you this one can be found out by this, it will be L I, n means L I, P d A, and then they have said that yes, this will be equal to P into area of the triangle by 3. I will tell you a little later. So, this is from the formula. If you have a function like this, where you have L I in a shape function of in area coordinate, if you write down, then P d A. So, this is the formula that they have given. Yes, it will be like this. So, total P vector for the 3 node will look like P del by 3 all are equal. If P is distributed over the entire triangle, then 1/3, 1/3, 1/3 will go on every node. So, this is I think for the time being this is okay. L 0 equal to 1 L I, yes. I am trying to see how to, this P means I am talking of total. This is for one node, this I am talking of the entire, all the 3. P. The general formula looks like this. Actually, this has come from P integral over area, and here it is L 1, L 2, L 3 d A. Now, if you I just want to relate this with the formula that I gave you, so that how to find out this. So, if you have an integral like this,
P is constant over the element of time?
yes, P is the given load, P is constant over constant. P is constant, then P we have taken out, and then it is like this L 1, L 2, L 3 d A, that is okay, Now, I will tell you how to, this is over area. Now, if you want to apply this formula of the integral. So, it is I am just again writing this, how to go backwards and then equal to, that means this should come before this final, this is the final formula, but then this can be written as P integral over area, and in order to bring this in this form, see I can write L 1 to the power 1. Now, I will add here, because it is L 1. So, L 1 means it is, because this formula is for A, B, C are the powers are the. So, L 1 to the power 1. Then I will add a fictitious L 2 here, L 2 to the power 0, because then it will anything to the power 0 is 1, and L 3 to the power 0. So, first this one should be taken as L 1 to the power L 2 L 3. Similarly, second one L 2 L 1 to the power 0, L 2 to the power 1, L 3 to the power 0, and this is L 1 0, L 2 0, L 3 to the power. So, this can be interpreted as this total. And if it is in this form, then yes, this is similar to this formula that is there. So, I can found out, and if you do this a plus factorial 2a, you will get a by 3, p a by 3 it is coming, delta by 3 it is. So, this if you apply this formula, you will find it is, and you can do it for 1, factorial 1 a, factorial 0, factorial 0, and it will be 1 plus 2 b and c. So, factorial 3 into 2 a, you see it will become 1 by 3. So, that is, so this can be kept in mind. So, I have taken a very simple example to explain how to compute these, because after all you have to integrate, and then comes we have taken only p where on the element. So far there can be also Newman type of boundary condition. So, that will for that derivation is slightly you will have to add few terms. So, that we will take up later, and now I will take a simple example. There is a plate there is a square plate size 10 by 10 k is equal to 2, p is equal to 2.4. This is given to us. Conductivity equal to 2, p, the loading on the total plate is this much, and the boundary condition is our Dirichlet type, phi equal to phi bar everywhere, phi equal to phi bar, and phi bar is equal to 0 on all, here also phi bar is equal to 0. That means, on the edges all these 4 temperature is maintained at 0. There is some internal heat generation through this p plate, there is some internal heat that is being, and then we have to solve the temperature for the temperature distribution within this plate. Now, we can always one is blind discretization. So, blind discretization should never be done. Yes, you say you have learnt about triangle. So, let me divide into some triangle. So, we start with 2 triangle, divide this simple 2 triangle, but that is not right in the beginning. We should also see whether there is any symmetry exists. So, that number of nodes, number of elements, number of discretization can be considerably reduced. So, since this appears to be a simple, it is a square. So, it has got symmetry about both the axes. So, this problem has symmetry about this x as well as y. So, if this is your x axis and this is your y axis, so there exists a symmetry. Then another interesting thing is not only x and y, there is also a symmetry. You will find 45-degree symmetry also exists here, diagonal. In fact, whatever happens here in this triangle, same thing mirror image of that will happen in this, and similarly this will be repeated. So, actual domain that you need to study is only this red line. And the moment there is symmetry, symmetry means what? Symmetry means del phi by del n equal to 0 here. This is a line of symmetry. Symmetry means rate of change of temperature with respect to the normal is 0. Similarly, here also del phi by del n, that means flux is 0. Now, we can, so since this is, so 1/8, so it has got only, you need to analyze only 1/8 of the problem, not total. That will be a brute force analysis. Now, here it is a intelligent. So, here let me divide this into, you cannot solve with one triangle, nothing you will. So, let me divide this, let me take a center point here and let me say that we divide into, I draw a horizontal line here, I draw a vertical line here, and I again join. Of course, there can be many. So, I have done like this. So, what I want to say that yes, I have divided this into 1, 2, 3 and 4. These are the 4 elements. Now, numbering, how have you numbered? You have to number, element is all right, there are 4 elements. Now, numbering, let me number this 1, 2. Why I am numbering like this? I could number this 1, 2, 3, 4, 5, 6. You see 1, 2, 3, 4, 5 and 6. But I do not want to do this because I know all the values on these are 0. So, I will number them in the end. So, 1, 2, 3, here I will write 3, then I will write here 4, then 5, then 6. So, that 4, 5, 6 are 0 values, boundary values. So, they are all 0 values. So, you have a 6 nodal problem. Two dimension and everything is done. Now, first job is we have to find out the element properties. I think just now we derived this one here. Yes, one is here and other one is. So, this is the formula for finding out, is it okay? This is the formula for finding out the stiffness coefficient, and this one is a formula if you have for finding out the p vector. So, both these will be utilized. So, if you use this, can you just try at least one term k 1 what will be for the, because anyway it is constant. So, we will have to see, we will have to give coordinates first of all. So, it is not easy, see process is tedious. So, we have to start with, let us say this one coordinate is 0 1. So, x 1 sorry we have to write down x and y of different. So, let me see this node n x and y coordinate. This is needed in every finite element computation. First, you have to define your geometry. So, you for example, node number 1 the coordinate is 0 0. Node number 2 the coordinate is, this is 5 2.5, is it okay 2.5 2.5 0. Node number 3 2.5 again 2.5. Node number 4 5 0. 5. 5 is again x coordinate is 5, y coordinate is 2.5, and 6 is x coordinate is 5, and this one also is 5. So, we have to have this, yes. So, global node numbers and their coordinates, they are needed, because we have to compute. So, come to element number 1. Element number 1 uses 1, 2, 3. And then we have to find out this, all this, b I, b j, I going from 1 to 3. So, this has to be found. Similarly, c I, c j. So, please compute this. Now, I can only tell you right from here, there is some similarity between this triangle orientation and this. Then this triangle is rigid body motion, same triangle has been moved. Similarly, this triangle also is same has been moved. So, all these three will have the same, it will turn out, if you do the computation, 1, 2 and 4 will have the same value of k, because of their nature. So, something can be directly, see here, now this 3 will be different, k 3. So, please, I think when we come to the tomorrow next class, because this is tedious, I mean you have to do this, there is no shortcut, we have to compute. So, please find out the values of all these coefficients and find out k matrix for all the 4 elements. Similarly, please find out also the p matrix for all the 3 elements. So, this much you please do it, and then we will, because you some of you. So, first lecture I leave it early, because you have to go to some other class.